Chapter 2, problem number 42. At the beginning of a basketball game, a referee tosses the ball straight up with a speed of 4.6 meters per second. A player cannot touch the ball until after it reaches its maximum height and begins to fall down. What is the minimum time that a player must wait before touching the ball? So given information consists of the acceleration due to gravity, and I'm going to call down negative, so that's negative 10 meters per second squared. And then the original velocity of the ball, VO, is upward, so it's positive 4.6 meters per second. Now, it reaches its maximum height. So at its maximum height, it's at rest. So we have that the final velocity is 0. And they want us to figure out how long that takes. That's how long the player has until he can touch the ball. So knowing G, VO, VF, and looking for time, a good equation to choose would be the definition of acceleration. So the final velocity minus the original velocity divided by the time is equal to the acceleration. Now solving that for time, you get that the final velocity minus the original velocity divided by the acceleration is equal to the time. Substituting, so we have 4.6 divided by 10, and we get 0.46 seconds. Now, I'm going to draw a diagram. Okay, and this is something that you want to learn how to do. Okay, so here's the ball at the get-go. It's being thrown upward with an original velocity VO. So I have an arrow pointing upward, next to it the symbol. Here it is at its highest point, where VF is equal to 0, and it's accelerating downward. And the time interval is from here to here, delta t. The next thing I would like to do is draw the motion graphs for this problem. Since down is negative, and that's which way it's accelerating, I'm just going to draw a straight line parallel to the t-axis. Velocity. The ball is thrown upward, so it starts with an original velocity, VO, slows down to rest. So a straight line at an angle drawn to the t-axis. So the end of the story is right here. I'll call it TF. Y versus t is a parabolic curve. Remember, the slope of position versus time gives you the velocity. So it starts out traveling in the positive direction, positive slope, right, because it's a positively directed velocity, and it goes to 0 slope. So there you go.